As part of the homework assignment, a couple of questions ask us to find the equation of a tangent line. And we're given an equation, and then they tell us a certain value of x that we're interested in. So, first of all, remember that a tangent line is basically the line that only touches a curve at a single point and has some slope which is equal to the instantaneous rate of change. Okay, so this is sort of an illustration of y equals x squared plus 3x plus 7. It's a parabola. And then over here at x equals 2, we're interested in having the equation of that tangent line. Okay, so first of all, let's look at the graph of this thing. So I've just kind of zoomed in on a specific part of this graph. X goes from 0 to 5, y goes from 0 to 30. So I get a nice little picture. Here's the point that I want to know the slope at. Okay, so first of all, I need to get a derivative. I need to calculate my slope there. So let's do the slope calculation. We know that y prime, based on our sum rule, our constant multiple rule, and our power rule, that y prime is going to be 2x to the first plus 3, derivative of a constant is 0. Okay, so at x equals 2, my slope is going to be y prime equals 2 times 2 plus 3. And that adds up to 7. So all I know so far is that this tangent line, or my instantaneous rate of change there, is going to be m equals 7. Now the equation of a line, if that's what we were looking for, is going to have the form y equals mx plus b. Now you may say, well, why are we finding the equation of a line? We already know what the slope is. This is sort of a practice in sort of theoretical math. It's the idea that, okay, now I have a graph of my function. I know the slope of my tangent line. I actually want to be able to put on my graphing calculator, be able to plot that tangent line and be able to see it in my window. Well, so far we know that since this particular tangent line is going to have a slope of 7, that it's going to look like this, 7x plus b. Now the second thing that we need to know is, well, what is the y value here? So if I come over here and I'm going to change the color, and so now I need to know, well, if I have a slope, what's another point on this line? Because you'll recall that the equation of a line, you need to have a slope and a point. So at x equals 2, what is my corresponding y? Well, if I just come over here to my graphing calculator, go to second trace, and then select the first option there, value, this will allow me to pick a value of x, so x equals 2. I hit enter, and it actually tells me what is the corresponding y value on that curve. So when x is 2, y is equal to 17. So now we know that this point right here, that's going to have a y, or output, of 17. So if I come over here and say, oh, okay, well, I know that the slope is going to be 7, and then I'm going to have the point 2, 17. So I have all the information that I need to generate the graph, or the equation of my line. So 17 equals 7 times 2 plus b, using our point slope form. And so subtracting 14 from both sides gives us b equals 3. Well, now I know that the equation of my tangent line is going to be y equals 7x plus 3. So this should be, if we didn't make any mistakes, the equation of this line. And if I come over to my graphing calculator, and under y2 I plot 7x plus 3, and I graph it, I should be able to see that tangent line. So there it is. And it's kind of hard to see because it looks like it touches at multiple points, but it's just the scaling on our calculator that makes it look that way. So x equals 2, y equals 17. That line satisfies meeting that point. And it also has a slope of 7, so it indicates that that's the rate of change. Now you might say, okay, what is this good for besides just practice and theory? Remember, what we do sometimes is, if our data is only available up through a certain point in time, we're going to make a tangent line approximation for the next year. So let's give these values some meaning. X is going to be years since 2000. Y is going to be profit in millions of dollars. Alright, so I know that in 2002, i.e. at x equals 2, I had a profit of $17 million. Well, now let's just say that this model only works between 2000 and 2002. So the question is, how do I predict 2003 profit? Well, what you might guess is, okay, well, I know that I have 17 million in 2002, and my rate of change, or my instantaneous rate of change in 2002 is $7 million. And so this is saying that instantaneously it's changing by 7 million per year. So that tells me that in 2003 I should have, or approximately, if this rate of change continues, $17 million. And so there's my approximation for 2003. Now, the only benefit to this line is I can also, instead of having to set this problem up, like what if I wanted to make a prediction for 2004 or 2005 using the same rate of change? I have to keep adding 7 million to my current value to get the next year. Well, if x equals 3 represents 2003, well, now I've got the equation of the tangent line. Y equals 7x plus 3. So what I can do here is say, well, let me use the equation to help me make my approximation, and you'll notice that we get 21 plus 3, which is $24 million. And I didn't need to do any of this by hand calculation. I could just plug in the year, and it makes a prediction for me. So if we assume that this trend continues up through 2004, then in 2004, well, I should have 7 more than I had in 2003. So I would take, in my equation, 7 times 4 plus 3. That gives me 28 plus 3 is $31 million. And you can probably see now that all this is doing is it's just allowing us to plug in the year and get the approximation based on the assumption that our profits are going to increase by $7 million a year. Now, the misnomer, what we tend to want to do is to predict for 2003, we say, hey, why don't we just use our parabola and allow our parabola to make that prediction for us. Well, remember, if the model is only good for or between certain years, we can't assume that things are going to change quadratically all the time. So it's a little bit safer to use the tangent line approximation, because even though it's going to give us a different estimate than our curve would, we are more justified in making the assumption that we have a constant rate of change versus this wild parabolic rate of change. So that's kind of why we use it.